Welcome to Lit Podcasts. Imagine standing on Earth 4.6 billion years ago. You'd be instantly vaporized. No solid ground, no air to breathe, just a hellish ocean of molten rock. Today, we're exploring Earth's mind-blowing transformation from cosmic chaos to our living planet.
And what a transformation it was. We're talking about a journey that turned a ball of fire into the only known haven for life in our solar system.
Let's start at the very beginning. How did Earth actually form?
Well, according to the latest research, it all started with a massive cloud of dust and gas, what scientists call a solar nebula. About 4.57 billion years ago, something triggered this cloud to collapse and start spinning.
What caused that initial collapse?
That's still one of the big mysteries, but many scientists believe it was likely a nearby supernova explosion that sent shockwaves through our region of space.
Wow, so we might owe our existence to an exploding star?
Exactly. And that explosion didn't just trigger Earth's formation, it also seeded our neighborhood with heavy elements that would eventually become part of our planet.
So what happened next in this cosmic construction project?
Well, as this cloud spun faster and faster, most of the material, we're talking more than 99%, gathered at the center to form our sun. The leftover dust and gas started clumping together due to gravity.
And one of those clumps became Earth?
Right, but early Earth was completely unrecognizable. It was essentially a ball of molten rock, constantly bombarded by asteroids and comets in what scientists call the late heavy bombardment period.
That sounds intense. How long did this violent period last?
It went on for hundreds of millions of years. But here's something fascinating. All that bombardment might have actually helped create life's building blocks, including DNA.
Wait, so the very violence that made Earth seemingly uninhabitable might have helped set the stage for life?
Exactly. And speaking of violence, one of the most important events in Earth's history was when a Mars-sized object slammed into our planet.
The impact that created our moon, right?
Yes, and here's something most people don't know. Before that impact, Earth's days were only about 6 hours long. The moon's formation actually slowed Earth's rotation to our current 24-hour day.
That's incredible. So we literally wouldn't have days as we know them without that cosmic collision.
And it gets better. The moon's gravitational pull also stabilized Earth's axis, which gave us our seasons and more stable climate.
Let's talk about Earth's atmosphere. How did we go from toxic soup to breathable air?
That's another fascinating story. Earth's first atmosphere was nothing like what we have today. It was mainly methane, ammonia, and carbon dioxide.
Sounds more like Venus than Earth.
Actually, yes. But here's where it gets interesting. About 3.5 billion years ago, tiny organisms called blue-green algae evolved the ability to perform photosynthesis.
And they started producing oxygen as a waste product, right?
Exactly. But it took hundreds of millions of years before oxygen actually started accumulating in the atmosphere. It was like filling an enormous swimming pool, one drop at a time.
Why did it take so long?
Because at first, all the oxygen was being absorbed by iron in the oceans, creating massive deposits of rust that we can still find today.
So Earth's iron had to rust before we could breathe?
Pretty much. Scientists call this the Great Oxygenation Event, and it was probably the biggest chemical change in Earth's history.
Let's talk about water. I always thought Earth got its water from comets, but I recently read something different.
Yes, that's one of the biggest recent surprises in Earth science. Research from 2020 suggests that Earth might have had enough water to fill the oceans right from the beginning.
That challenges what we thought we knew about Earth's formation, doesn't it?
Absolutely. It's a perfect example of how our understanding of Earth's history keeps evolving as we get better at studying it.
Speaking of evolution, there's some fascinating new research about how evolution affects ecosystem stability, right?
Yes, this is really cutting-edge stuff. Researchers at Monash University just published a study showing how evolution can actually shift the tipping points of entire ecosystems.
Tipping points? What do you mean by that?
Think of it like a cup of water on the edge of a table. A small push can send it crashing down. Ecosystems have similar points where small changes can cause dramatic shifts.
And evolution can affect where those tipping points are?
Exactly. The study found that evolution can either make ecosystems more fragile or more resilient to change.
That seems really important for understanding how ecosystems might respond to climate change.
It is. The researchers actually demonstrated this by evolving microbial communities for 4,000 generations.
What did they find?
Well, when species evolved to compete more intensely, the ecosystem became more fragile. But when they evolved to handle stress better, the ecosystem became more resilient.
So evolution isn't just about individual species, it can affect the stability of entire ecosystems.
Exactly. And this connects back to Earth's early history. The evolution of those first photosynthetic bacteria didn't just change them, it transformed the entire planet.
It's amazing to think about how these processes that shaped Earth billions of years ago are still at work today.
And they're happening faster than ever because of human activities. We're basically running a giant evolutionary experiment with the planet.
That's a sobering thought. What can we learn from Earth's history about our current situation?
Well, Earth has gone through massive changes before and survived, but those changes typically happened over millions of years, not decades.
So we're pushing the system faster than it's ever been pushed before?
Much faster. And while evolution can help ecosystems adapt, there's a limit to how quickly that can happen.
It's like we're conducting a planetary experiment without knowing where the tipping points are.
That's exactly right. And once we cross those tipping points, it might be very hard to go back.
But understanding these processes better gives us a chance to make better decisions, right?
Absolutely. The more we understand about how Earth evolved and how ecosystems work, the better equipped we are to protect them.
Let's wrap up with a big picture question. What's the most surprising thing you've learned about Earth's evolution?
I think it's how many times catastrophe led to opportunity. The impact that formed the moon gave us our days and seasons. The toxic early atmosphere enabled life to evolve.
So even the worst moments in Earth's history had silver linings?
Exactly. Earth's story isn't just about survival, it's about transformation. Each crisis created new possibilities.
That's both humbling and hopeful.
It is. And it reminds us that we're part of something much bigger than ourselves, a 4.6 billion year story that's still unfolding.
Well, that brings us to the end of today's episode of Podcasts. From molten rock to living planet, Earth's journey continues to amaze and surprise us.
And we're not just observers of this story, we're active participants in writing Earth's next chapter.
Thanks for joining us on this journey through time. Remember, every breath you take contains atoms that have been part of Earth's story since the beginning.